This is the first time I speak in front of people in English. I used to be a teacher before, so maybe I can ask some questions, and if you don't get the right answer, I can send you to a corner. Okay? It's just how it used to be. So this talk is going to be about asynchronous programming, mainly. We're going to compare RxJava just a little bit with Coroutines, which is something really cool. I'm going to cover some examples. It's important to say that this is comparison only. I'm not going to tell you what to use or how to, when to use it. It's up to you. Just try it out. So first, coroutines don't exist in Java. So if you want to use coroutines, you should already be using Kotlin. But I assume you already use Kotlin or want to use Kotlin. That's why you are here, right? So I don't think that's going to be a problem. Every time we talk about coroutines and RxJava, we have this little debate about which one is better. And we say like, oh no, it's like trying to compare apples with pears. So you can't really compare. That's why they say, but Kotlin has been evolving really quick. And right now, I think we can exchange some functionalities and use coroutines instead of RxJava. So first, we want to talk about synchronous. What is synchronous? Synchronous is how code normally works. It's from top to bottom, sequentially. Every time you do something, it's going to block the thread you are working on until it's done, and then you can go to the next task. This is basically how programming works. Every time we execute our code, it runs synchronously, meaning that it runs from top to bottom. In other words, when you have to execute something synchronously, you wait until it's finished before moving on to the next task. So you can't perform more than one operation at the same time, and that's a big problem. So if we're gonna do computation, we can, for example, we can take like up to 10 seconds. It's gonna be a problem because we're gonna block the thread where we are working on currently. So in Android, we have the main thread, and if we do something, we're gonna block the UI, and that's gonna lead to a bad user experience, and bad user experience is gonna lead to one star rates in our apps. Well, from here, are any of you Android developers? Yeah. Okay. So you have seen this screen, right? This happens because when we block the UI, we're doing something in the thread, and then the UI can't refresh. The UI refreshed about every 16 seconds, 16 milliseconds, in order to render the 60 frames per second. If the computation takes more than 5 seconds, we might see this screen, which is very bad. So regardless of what language we use or what platform we work on, whether we are creating like server-side, desktop applications, or mobile applications, or in this case, like Android applications, it's really important that we create a great user experience and we try not to block the main thread. So instead of using synchronous programming, we should stick to asynchronous programming. When you execute something asynchronous, you can move on to another task before it finishes. When you use asynchronous operations, we're just moving the work to another part of the thread to be able to keep doing the basic and not important stuff like updating the UI. Well, it's a joke. It's very important to keep the UI responsive. So we already know what is synchronous and asynchronous programming, and that's what we want to achieve. We're going to be able to do multiple operations at the same time without blocking the UI thread. How can we achieve that? There are several Android tools that we can use and we have used before. Yeah, the first one is Java Thread API. This one is provided by Java and can be used by Kotlin. We have async task. Async task, it's like my first love. It's the first thing I really use while doing any Android development, and I'm pretty sure most of Android developers have used that because it's so simple to use. Um, it was not difficult at all, just extending the async task. So you can create your own task and add the code. It has undo and background, to execute, to update the UI. So it was handling everything. Um, but there was something really bad about async task. There's still something really bad. When you have two async tasks, you don't really have control over which one is going to respond first. So if you have two calls to the network of any I/O operation, you can't really expect one first than the other. Well, you can, but not in the order you want. So you would have to run one and then wait and then run the another one. You can't just run the two at the same time because you will have that problem that can lead to a race condition where you don't have the data you need to continue. Another thing is that it's not really easy to cancel. And one more thing is that when you rotate the Android screen, it's going to destroy the whole UI. And if we pass the UI reference to the async task, and we rotate the phone, the UI it has another reference. So when the async task is done, it's going to return a value to a invalid reference to a view that doesn't exist anymore. So that can lead to crashes. So it's really difficult to handle that. And something that is even more important is that async task is already being deprecated in Android. That's a new. Like 3-4 days ago, there was a commit in the Android repository. So it's going to be deprecated for Android 11, and hence it's going to be gone in future releases. So we should stop using async task. Something else is Android services. Android services is really good to do background tasks, but it's more used for long running tasks. For example, playing music in the background. Every time you have a music application playing music like Spotify, Apple Music, or Google Play Music, there's a service running in the background handling all the music. Every time Google tells you something about like, hey, you were here, like, how do you know? Because Google was running in the background, your location was fetching your location. So those running tasks are good for services. Services is not really good for requesting like network, for making network requests. We also have Event Bus, which is a library, way to do it. And we have callbacks. I think there was already a talk about callbacks, why they are bad, so I can't really say a lot about it. But callbacks, the big problem is that you get nested callbacks, and they call it a callbacks hell, when you get like 2, 3, 4, 5 different levels of deepness. You go deep to 4 or 5 times levels of deep. Okay. And besides that, callbacks, it's not really handling background threading. It's just a way to get information back. You still have to handle that. Okay, the next one is RxJava. RxJava is asynchronous collections. It's used in Android, and it contains a collection of operators and observer. An observer subscribes to an observable to be notified about the next item when it's complete or when it gets an error. So basically, just a listener listening to any message that RxJava can emit. And lastly, we have coroutines. Coroutines, Kotlin coroutines, because most of the people started using Kotlin about 2 years ago, maybe 3 years ago, in 2016. Even before it was officially supported by Android Studio, they were just using it for Android. We discovered how Kotlin was great to improve readability, and one of the most hated things, the Java null pointer exception. So even when we switched to Kotlin, we are still using RxJava and RxAndroid. until we got coroutine support for Kotlin. And I say coroutine support because coroutine is not something new. Coroutine was already there in other programming languages. So it's already a well-tested concept that it's been used in C++, Erlang, Go, JavaScript since ECMA 1.7, I think, PHP, Python, and Ruby. So the point is that you can't really say, I'm not going to use coroutines until I know for sure it's something that works, because that already worked for years in other languages. Okay, so I wanted just to give a quick introduction to the asynchronous concept and why this is important in Android development. And this is the actual title. So we want to talk about RxJava, which is this big monster that everyone in Android has used before or is still using, and Coroutines, which is a little baby because it was released just about a year ago, on October 28. So you may think still trying, like a baby is trying to crawl or babbling, not able to speak, but this is taking like big steps into the future, and this baby is already walking, running, and singing. So while Coroutines is still gaining popularity among developers, on the other hand, RxJava was released on November 18, 2014, and has become one of the most important skills for Android. So, have any of you used RxJava before? Yeah, I think most of the Android, the same guys who do Android. Okay. RxJava is event-based, use observables. It's polyglot, so you can use it in different languages. RxJava stands from reactive extensions, so you can use RxJava in JavaScript, Java, and any other more languages. This is asynchronous. That means like you can just run that automatically in another thread or in the background, so you can keep doing your stuff while you're waiting for any response from the service or from any computation you have or you are doing. So, one thing about RxJava is that RxJava is not going anywhere. We have a lot of RxJava. In my previous company, we removed RxJava because we thought it was too complex and we didn't even need it. We were not doing anything like for streams. We were just fetching data, so we don't really needed that. But in my current company, we have RxJava all over the code base, so I don't think we're gonna switch there really soon. It's basically impossible unless we spend a lot of time trying to do it. So RxJava is not going anywhere right now. Okay, and what's wrong with RxJava? Nothing. RxJava is really good. Okay, I think we're done, right? We have the answer here. Well, RxJava is really good. It's perfect. It does the work in an efficient way, and it can be used for everything, and it can be used in different languages, as I said before. So if you learn RxJava if you learn Rx for Java, you can easily just do it in JavaScript, for example. The only problem would be is that it's really difficult to learn. I've been trying to learn RxJava for years, and I'm not even close to master that. It has like hundreds, maybe not hundreds, close to 100. I didn't count them. There were a lot in the website. I would say tens of operators, and you have to learn what every operator does. So that's kind of difficult. So even if you master RxJava and you introduce that into your code base and you say, oh, it's really cool, it works really quick, and we get the response we want, we merge, we zip all the responses, we concat every operator you can use, then what happens when you get a new developer, like me, who doesn't know RxJava very well? You go into the code base and you don't know what to do. You need to go and spend a lot of time trying to learn Java. And you have to spend a lot of time just trying to understand what's happening here. even before you can just update something. So, one problem I saw online while researching is that a lot of people try to use RxJava for everything. For everything. I mean, RxJava is a reactive extension, so it's supposed to handle streams when you get something and you are feeding, for example, UI while you're waiting for elements, but then you get these responses with a single response, and I don't really think we should be using RxJava there because we're not streaming anything. So if you go into the code base, sometimes you see a lot of RxJava everywhere, and you don't really need that. Okay, so what's a coroutine anyway? Coroutines are computer program components that allow execution to be suspended and resumed. Kotlin coroutines allow you to write asynchronous code in a way that looks like synchronous. That means that it doesn't change. Not a lot. One of the benefits, however, of coroutines is that when it comes to a developer, writing non-blocking code, it's very similar to writing blocking code. It's very, very similar. So even if you want to migrate a function from blocking to non-blocking, you don't have to do a lot of work. The programming model remains the same. You can still using loops inside the coroutine. You can still using loops, exception handling, and anything you would use in a blocking function, you can use it in a coroutine. You don't have to learn a new set of API, also known as operators for RxJava. Coroutines give us all the benefit of asynchronous and non-blocking behavior, but without the lack of reliability. Okay, so let's go to the fun. We have our interface. As you can see, it's a retrofit. I'm using retrofit for this service. We're going to try to fetch people and film. Every time we get a people and get a film, it's only one people and one film. We're not getting any list. So the way we do it, okay. This is a very basic network request without coroutines or RxJava. Okay. So can anyone tell me if this is gonna work or not? This is all the code. You're not missing anything. The only thing you're missing is the API call, but this is basically everything. The API setup. Do you have any idea why this is not working? Yes, John? Why? Yeah, it's gonna crash. Well, in Android, yes, it's gonna crash. But if you go to any other application, maybe desktop, it may just block the UI. But in Android, it's gonna crash. Maybe, yeah, it's gonna crash, and you will get a crash, something like network I/O on main thread. So it's not possible to do that. And that's basically because, as I said before, we need to refresh the UI every 16 seconds. So 16 milliseconds, 16 seconds, 60 milliseconds. So if we get this, most likely it's gonna crash because a network request takes more than 60 milliseconds. Something we can do to solve this is adding a coroutine. So as you can see, we have this. We added this span keyword, and that's it. That's basically all the work, all the new, the learning curve. That's it. One keyword, and that's already a coroutine. You don't have to do a lot of things. So you get a response. We need to wrap the response, the people response, into a response bar. This is something by retrofit. It's nothing to do with coroutines. So the only difference, basically, I'm gonna go back, is the suspend key, and that's it. Then here, we get private suspend, get people. Oh, I think I'm missing something. Okay. There's another problem here. This is still not gonna work. Do you wanna try to guess why? This is not gonna work because when we call a coroutine, we have a launch. This is the default launcher that might create not create, might move into another thread that it's already created and handled by the thread pool. The thread pool basically are threads that are already created and running in the system. It's like, hey, bro, I wanna do some work. Do you have something I can use? Oh yeah, take this one that's already running there, laying around. You can use it and just put it back when you're done. That's basically the default dispatcher. So the problem here is that all this global scope that launch, all the code inside this launch is going to run in the thread that the default launcher selects. So do you have an idea why it's going to crash again? You were scratching your nose? Or?
It's going to update the UI.
Yeah, it's because the UI runs in the main thread, and this launch is going to try to select to do the work in another thread, random thread. When I come back to the update UI, it's going to crash because an UI view can't be updated by any other thread, only its own thread or the thread that created the view. So all this code, all this block inside launch, it's running in another thread. So what can we do here to solve it? We can do this. Sorry, I'm a little sick. We can do this. It's the same code. The only difference is that I'm getting a variable with people and update UI. But still, we have another problem here. The problem here is that people, I wish I had a pointer. But people is here running in the main thread. Update UI is running in the main thread. But global scope is running in another thread. I added this. Just try to imagine this is not here. So the problem is that this is going to run, and then it's going to launch the coroutine, and then it's going to update the UI. But the UI is going to be updated before we get a response. So that's going to be another problem. So the real problem to solve this, or launch the coroutine, would be launch the coroutine in the main thread, which we can do it. This is suspending the computation, and then update the UI. Okay, so coroutines are not threads. Coroutines is not running the computation in another thread. It's doing it by default, but you can't not do that. So coroutines are computations that run on top of threads and can be suspended. We're not creating a new thread. We don't waste those resources. If we can do it in the same thread, why not? This doesn't mean that we don't need threads anymore, or that we don't have to use them. Sometimes we have just too many computations or too much work to do. So a coroutine is sequential, meaning that it's, again, that it's executing from top to bottom. So this running in the main thread, the coroutine is running this. People get fetching, and when it's done, then it goes into the same one. And if we have more code, it's going to be running one by one and waiting for the results each of them before continuing. Okay. This is something similar, but with RxJava. So first, with RxJava, we have these schedulers, which is the Android scheduler from the library Rx Android. We have to define or let the process know what thread we want to use or how we want to compute this. So by default, if you don't type anything, for example, if you don't get the observe on and subscribe on, it's going to run in the main thread, or in the thread you launch this computation from. If you have another thread and do it, then it's going to be there. So in some cases, maybe you don't need observe on and subscribe on. But this is running from the main thread, so of course we need to take the work off the main thread. We have schedulers IO, which basically means like the same the default dispatcher for coroutines. Just take this into another thread you find there in the system and run done, just let me know. So there's not a big difference. Something I don't really like about RxJava right here is that I'm not returning a value. I'm returning a observable, which is a single in this case. If we go back to coroutines, we see that we are returning the people, the object itself. So we can just try to do something with the people like right away. And here we need to subscribe. This is Lambda, this is Kotlin, so it looks like good. But if you're working with something else, or you're not using any Lambda, you're gonna have a lot of code here. And this is like a simple, really simple example with a single. So what happens when you have a observable, when you need to have a next, on complete, on cancel, on error, so all these callbacks. So all your code is gonna be full of callbacks. So that's why I don't really like it. Okay, so this is a side-by-side comparison. So coroutines are computations that run on top of threads and can be suspended. Okay. So, do you have any questions so far with this comparison? I think it's really cool that we don't need it to have a return value, just the object itself. It's really cool, actually, for me. Okay. Next. This is a little more elaborated example, because as I said before, this one on the left side, it's you're only requesting for a single object, a people, one person. So why do you really need an observable here? If you're gonna get something and that's it, you're not streaming anything. So this, for me, this could be done with just a coroutine, just do a computation and get it back, and that's it. So here, it makes a little bit more sense to use RxJava because we have the film. So this is gonna get people, but first it's gonna get the film. Then from that film, it's gonna get the people in that film and just fetch that. And you can use flat map to get the value from the previous request and just add a new request there. And this is something like, oh yeah, I want to use RxJava because I have this complex code that we need to chain a multiple request, right? That's why I use RxJava. But you can also use coroutines to do that. You don't really have to go to RxJava. So it's doing the same. And this is returning a list of people. So you get the service, you get the film, you get after you get the film, you just map to get all the list of all films. This film has a list of characters. So then every character gets a people ID, which is an ID. Then you make another request to fetch all people in this request. And this is good, but it's not that good. The problem here is that when you fetch one people, and then let's say, okay, let's remember that this is doing one request one by one. It's not fetching a list. So let's say if I fetch the film, okay, I'm gonna get a film object. You can see there. Then I need to fetch the people, but every request is gonna return one people only. That meaning that if I have 1,000 people there, I'm gonna wait until 1,000 requests are done so I can update the UI. When the 1,000 requests are done, then I can proceed and update the UI. Because this here, get people by field, it's gonna wait until the 1,000 requests are done before doing that. So it can take 5. It's not blocking the UI. That's good. We can just display a spinner. But if we display a spinner for how long? Like 5 minutes, 10 minutes? I don't know. So I think that's why we use RxJava, right? Because then we can fetch, and when we are fetching the request, we can be updating the UI and on next, right? That's something we use. It's stream data. But again, that's something we can use with coroutines. There's something new in coroutines called flow. It's still experimental, but experimental doesn't mean it's not good or it's not working. It just means that it can be changed in the future. The API might change, but you still can use it in production. It's really, really good. So again, I have a suspend function, which is not return people, and I have a suspend function that's going to return the film. What changed here is that we're still running the main dispatcher, get people by field. It's going to collect, and every time, every item, and update the UI each time we get a new item. So the same, we get the film. After we get all films, we map and we get a list of IDs. Then we make another request. And with this other request, we get people. After we get people for each request, we can emit the people we just get. When we are emitting the people we just get, we are sending that so the launcher can collect that information and update the UI. Basically, this means that every time we get a new response, if we're still waiting for the 1,000 response, but every time we get one people, we update the UI. So the user can start searching or can start reading or doing whatever they want in the app. Okay, so this is good. This is still experimental, but you can already use it. Okay, how to cancel a request. In a long-running application, sometimes you might need to cancel something in the background. For example, if the user just closes the app or goes to another screen, something like that, and you don't really need that information anymore. Sometimes even the user cancels itself because he doesn't want to be doing that anymore. So cancel something is really good. If we don't cancel, problems might be that the user goes to another place, we get the background computation running, and when it wants to update the UI is going to be gone. So that's going to crash the app again. A lot of crashes. So in RxJava, we have disposable objects, and we can just add every callback. Well, every subscription has a disposable callback. You add that callback, and then if you want to cancel it, you just click cancel, and that's it. That's how you cancel RxJava. In jobs with the Coroutines, it's very, very similar. You can assign this job. Also has a callback, a job object. You can just pass that object and cancel that. So that's pretty similar. So there's not a lot there. Then for RxJava, you can cancel. Let's say you have like 2 or 3 different requests running at the same time, but you want to cancel all of them. You just add all of them, each of them to the composite disposable, and you just set to clear and dispose it. When you clear, basically you are telling just remove everything, all the network, the request. And when you dispose, basically it's like assigning to null, like, hey, there's nothing else to do here. For Java, for coroutines, we also have something which would be like a job that you can just assign. You can open a big block of code with a parent job, a global launch, and just set the dispatcher you want to use, and then you can have several codes inside. Then when you want to cancel, you just cancel, and it's gonna cancel all the children automatically. Okay. So do you have any question so far? Well, not so far. Do you have any question? Because I'm basically done. Yes, sir?
If you were starting a new project now, which would you reach for? Would you use RxJava, or would you use Coroutines, or would you use both, or would you
Well, this is, I said at the beginning, this is a personal preference, but I would use Coroutines. Why? Because it's something that's already kind of built in Kotlin. It's very similar. When you add Kotlin, when you are the Coroutines library, you don't feel like you are adding something external. You just feel like you're writing in the same language in Kotlin. You don't really have to learn anything else, just these keywords. Of course, there's a lot more about scopes and those things. But if you want to start a new Android application, I would just stick with Coroutines, just because of that. RxJava also has operators like flat map and map and all that, but Kotlin, the language itself, already has those operators. So if you already know Kotlin, learning coroutines is gonna be like nothing, really, really, really easy. Yeah.
Is there any performance differences between Coroutines and RxJava, or is it
Well, they are in different ways. They are different in multiple ways. I was checking some performance tests online, and there's a difference, a big difference in some cases. The test was trying to update something in the background thread and then in the main thread 1,000 times, and 10,000 times, and 100 times. And all the times Coroutines was winning. And I think that's just because, okay, Coroutines, it's made by Kotlin. Well, coroutines for Kotlin are made by them, by Kotlin. It's not like external library. It's not like somebody else is working on. It's something that the same team is working, so they know how it works. So I'm pretty sure that's why they know how to handle everything. So I would say yes, there's a better performance for coroutines, at least in the basic stuff. So if you still want to merge and zip and all that, maybe you can just use RxJava because the flow is still on development. Yeah. It doesn't work. It's still. Okay, so no more questions. Okay, cool. Well, my name again. It's Carlos. This is my email, cfba14, and my username for basically any social network. If you go to Twitter, you won't see anything because I don't do anything. But if you tweet something, most likely I'm gonna see it. So, okay. Well, thank you so much.